All right, we're going to work on solving these linear systems using a different method. Now, if you're like me and you don't like the substitution method, this is a much easier one to me. Some people like the substitution method, some people like this method better, but you have to be able to do both. So, the idea of the solving linear systems using the addition method is that we are going to look at these two groupings up and down. So we have that one there, and this, okay? And what you want is you're going to add these things together. So you get 6x, because 2x plus 4x. This will give you 0y, or nothing, and this equals 24. And all of a sudden we have 6x equals 24. We can solve for an x right now. Divide by 6, and x equals 4. And then we take that just like we did before, and we plug it back into one of the originals. I'm going to put in the bottom, but you could put in top, doesn't matter. So then we get 4 times 4, because that's what our x was, plus 3y equals 16. So I get 16 plus 3y equals 16. Subtract 16 from both sides, and I get 3y equals 0. So y equals 0. And like always, I write it as an ordered pair. You're probably thinking, wow, that was a lot easier than the substitution method. And it is sometimes. Sometimes this method will be easier, sometimes substitution will be easier. It's hard to know before you start. Just like before, if you ended up graphing these, you could find out what your answer is before you start. All right? So let's try another one. Now, this one, if I'm adding straight up and down, I get negative 1x plus 7y equals 11. And uh-oh, there's a problem. One of the variables hasn't gone away yet. Okay, so we have an issue. We can't do it like this. So what we need to do is we need to multiply the equations by some number so that we can get them to both go away. Well, I know that the x here are positive and negative of each other, and if I can find a common multiple, it's kind of an old term, then they'll go away. Well, I know 12 is a common multiple of 3 and 4. So I'm going to take this equation here, and I'm going to multiply every term by 4. That gives me 12x plus 20y equals 24. Every term got multiplied by 4 on the top. Okay, that became that. On the bottom, then, I need to do the same thing because I'm aiming for 12x, but a negative down here. So then I'm going to multiply every term here by 3. And that gives me negative 12x, which is what I wanted, minus 6y equals negative 15. Well, now these go away, and I'm left with 14y equals 9. I divide by 14, and my y equals 9/14, which looks weird, and I'm just double checking my math here, but it looks right. Oh, it is not right. I found a mistake. This should be a positive 15, and this should be a positive 6. Try that again. 26 equals 39. Whoops, 26y equals 39. Now I divide by 26. Here we go. And so if I simplified that down, that would be 3/2, or 1.5. Okay? That looks a little bit better. Now I take that number and I plug it into one of the equations. I'll do the top this time. And so I'll go 3x plus 5 times 3/2 equals 6. So then I get 3x plus 15/2 equals 6. I'm going to subtract 15/2 from both sides. And so I get 3x equals negative 3/2. And I know that because that's negative 7.5, and that's 6. Now I divide by 3 on both sides. And shortcutting a little bit here, I get negative 1/2. Okay. So our answer is -1/2 3/2. Now, if you're stumped by the fractions, once again, this video is about the addition method, not the fractions themselves. So if you need help on fractions, ask me, and we'll work through them individually. Okay? So the idea is you're trying to get rid of a variable by adding the top and the bottom row, not subtracting. It's called the addition method, and then solving your way down. So try this one on your own. All right, for this one, I'm going to take this bottom one here, and I'm going to multiply times -2, because I want this to be a +6, because that's a -6. So I get 6x minus 6y equals +18. So that goes away. Now I add the 1 and 3 together. Well, those go away. So I'm left with -4y equals 20. I divide by -4. And y equals -5. I plug this back into an equation. I'll plug it here. And so I get 6x minus 6 times -5 equals 18. So I get 6x plus 30 equals 18. I subtract 30 from both sides. So I get 6x equals -12 divided by 6. And x equals -2. So my answer is -2, -5. Right, like that. Okay? One last one. There's no story problem here. Before we start, the problem is the equal signs don't line up. So you have to move one of them over so they match up and then do the method. So try this on your own. Okay, so the way to fix this is we're going to add 5x over here. So I get 5x plus 2y equals 12. So that makes this go away. Now they look the same. The only problem is, if you look, we wouldn't get rid of anything yet. So I'm going to take the top equation this time. I'm going to multiply times -1. So I get a -2y and a 2y there. So I'll get -3x minus 2y equals -12, or -8, sorry. So I get 2x equals 4 divided by 2. X equals 2. I take that and I plug it into one of the equations. Let's do this one. It really doesn't matter. Shortcut a little bit. I'm going to get 10, because 5 times 2, plus 2y equals 12. 2y equals 2, subtracting 10. So y equals 1. So I get 2, comma, 1. And that's my answer. All right. Take some practice. Check online for your assignment. And ask me if you have any questions.